Hello everyone. So welcome back to the second video on data sufficiency problem, word problem 2. Okay. So we'll be taking up another 5 questions of GMAT 700 to 800 level and we'll be solving them in this video. All right. So we'll follow the same drill. We'll follow the same practice. I'm going to show you a question on the screen. You're going to pause the video. You're going to try the question by yourself first. And then you're going to play back the video and understand how to solve a particular question. Okay. All right, so without wasting our time any further, let's get started with the data sufficiency question number 1. Okay, so pause the video guys and try this question by yourself first. All right, let's see how we can solve this one. At a certain college, students can major in science, maths, history and linguistics. So we have math, we have science, then we have history and we have linguistics. These are the 4 subjects. If there are 1 by 3 as many science majors as there are history majors, so 1 by 3 as many science majors as history majors, which means if we consider history majors to be x, then it's 1 by 3 as many science, so 1 by 3x, and 2 by 3 as many math majors as history majors, so 2 by 3, because history major is x, so math will automatically become 2 by 3 of x. 2 by 3 as many math majors as there are history majors. How many of the 2000 students major in linguistics? Okay, so we have a total of 2000. Now if I add the 3 values, that is the maths one, the science one and the history one, so 2x by 3 plus x by 3 is x, x plus x is 2x, so linguistic will automatically become 2000 minus 2x. So how many other 2000 students major in linguistics? So we need to calculate 2000 minus 2x. So basically the question is all about calculate the value of x. The question is all about calculate the value of x. So whichever of the 2 statements, 1 or 2 or probably combining both of them, give us the answer, that will be our answer. Give us the value of x, that will be our answer. Statement number 1 says there are as many linguistic majors as there are maths majors. There are as many linguistic majors as there are maths majors. So statement number 1 will say that 2000 minus 2x will be equal to 2x by 3. Now we don't have to solve this. The point is, can we calculate the value of x from here or no? The point is, can we calculate the value of x from here or no? So yes, we can do that. Now I do not know what will be the value of x will be, but yes, I know that I can figure out x from here. Now once I can calculate the value of x from here, I can plug in that value of x here. And I can calculate the total number of students who took linguistics as their major. Okay, so that means statement 1 gives me the required answer. So A is my answer. So I have only 2 options, either A or D. If B alone also, or if statement 2 alone also gives me the correct answer, then my answer is D. Or if statement 2 alone does not give me the required answer, then my answer is A. Okay, statement number 2. There are 250 more math majors than there are science majors. There are 250 more math majors than science majors. So math majors are 2x by 3 and they are 250 more than the science majors. So that is 250 plus x by 3. Again, can we calculate the value of x from here? Yes, we can do that. We don't need to calculate, but yes, we can calculate the value of x from here. So from statement 1, I can calculate the value of x. From statement 2, also I can calculate the value of x. So statement 1 alone is also sufficient and statement 2 alone is also sufficient. So my answer is simply option number D, that is both statements alone are sufficient to answer the question. Both statements alone are sufficient to answer the question. All right. Let's move on to question number 2. This question is interesting. It's a long question also, so pause the video and please do take your time while solving this question. Okay. Okay, let's read this question now. A green bucket and a blue bucket are each filled to capacity with several liquids, none of which combine with another. So I have a green bucket and another one is a blue one. So I have a blue bucket. A green bucket and a blue bucket are each filled to capacity with several liquids, none of which combine with another. Liquid A and liquid B each compose exactly 10% of total liquid contained in green bucket. Okay, so let's say that the green bucket consists of the green bucket or the capacity of green bucket is X. So we can say that it will have, or the capacity of liquid A in it will be 0.1x, and the capacity of liquid B in it will also be 0.1x. Liquid C composes exactly 10% of the total liquid contained in blue bucket. Okay, so if we talk about the blue bucket, now we do not know what's the capacity, neither it's given to us whether the capacities in the two buckets are equal. So we will consider that the total capacity of blue bucket to be Y, and the liquid C in it, let's consider it to be 0.1 Y. Okay. Liquid C composes exactly 10% of the total liquid contained in the blue bucket. Okay. The entire content of green and blue bucket are poured into an empty red bucket. Okay, so we have another empty red bucket. So this is our empty red bucket. So what we have done is the entire quantity is poured into this, and this entire quantity is also poured into this, completely filling it with liquid and with no liquid overflowing. Okay, what percent of the liquid now in the red bucket is not liquids A, B or C? Okay, so we need to calculate what percent of liquid now filling the red bucket is not liquids A, B or C. Okay, now all the liquids that we have cannot be combined, right? This is also given to us that the liquids do not combine with each other. Liquids do not combine with each other. That is also given to us in the question. So what percent of the liquid now in the red bucket is not liquids A, B or C? This is what we need to figure out. Okay, so statement number 1. The total amount of liquids A, B and C now in the red bucket is equal to 1.25 times the total amount of liquid A and B initially contained in the green bucket. The total amount of liquid A, B and C now in the red bucket. Now, what usually students do at this point of time once they read this statement is that what they say, the total amount of liquid A, B and C now in the red bucket. Okay, so they say that, okay, the amount of liquid A, B and C in the red bucket is 0.1x plus 0.1x plus 0.1y. The total amount ABC now in this, so this is the amount in red bucket. This is equal to 1.25 times the total amount of liquid A and B initially contained in green bucket, which is equal to 0.1x plus 0.1y. 0.1x again, sorry, my bad, not 1y, it's again 1x. Now the problem here is that we are making an assumption. The assumption is that we are assuming at this point of time that the green bucket does not consist of liquid C. The green bucket does not consist of liquid C. This is assumption number 1 that we are making here. Because when you're writing 0.1x plus 0.1x, so that is liquid A and liquid B from green bucket. But what about liquid C from green bucket? We do not know that. What's the percentage of liquid C in green bucket? We have no idea about that. Second assumption that we are making when we are talking about the blue bucket, which consists of liquid C, so we wrote, okay, it's going to be 0.1 y. But what about liquid A and liquid B from the blue bucket? Nothing about that is mentioned. It's not even given to us that there is no liquid A or liquid B in blue bucket and there is no liquid C in the green bucket. That's not given to us. Right? So, which means if you're going to make this statement and if you're going to evaluate the value of x in terms of y or y in terms of x, and from there on you're going to figure out your answer. Because if you consider this equation to be true, assuming the fact that there is no liquid C in green bucket and there is no liquid A and liquid B in blue bucket, if you'll assume that, you will definitely get your answer from statement number 1. You will definitely get your answer from statement number 1, because you'll get a relationship between x and y, and from there you can figure out the percentage. But again, you're making an assumption in this case. So statement number 1 is technically does not consist of the information which should give you the required answer or the affirmative answer. Sorry, not the affirmative, the conclusive answer. My bad. It's not affirmative, it's about conclusion. So statement number 1 is not giving you a conclusive answer because you have no idea regarding liquid C in green bucket and liquid A and B in blue bucket. You are assuming if you are taking this statement to be true. Okay, so don't make that mistake. Okay, the second one says the green and the blue buckets did not contain any of the same liquids. The green and the blue bucket did not contain any of the same liquid. Now this statement alone, this second statement alone is not going to help me at all. I'm not getting any relationships. I can't calculate any percentage. I can't do anything. But if I combine this 1 and 2, now there is no more assumption. Now this equation that we have formed, this equation will be true. Now this equation that we have formed, this will be true. Right? And from here now you can figure out the value of x and y. And once you have the value of x and y, then you can definitely figure out your answer. So let's see. So what I'm going to do is I'm going to rub this portion so that I can do my calculations. So this is 0.2x plus 0.1y. So this is 1.25 into 0.2x. So 1.25 minus 1 into 0.2x is equal to 0.1y. I just took this 0.2x on the other side, that's it. So this is 0.25, that is 1 by 4 into 0.2x. This is equal to 0.1y. So this is like 2x by 4 is equal to y, or x will be equal to twice of y. X will be equal to twice of y. What percent of liquid now in the red bucket is not liquid A, liquid B, or liquid C? Now we know the relationship x and y. So we assumed the green bucket to be x. So liquid A was 0.1x, liquid B was 0.2x. The quantity of bucket blue was y, so liquid C was this was 0.1x, my bad, not 0.2x, sorry. This was 0.1y. So we have 0.1x, 0.1x, 0.1y out of total x plus y. Now x plus y can be rewritten as thrice of y because x is 2y. So total quantity inside the red bucket. So total quantity inside the red bucket is thrice of y. Now in the numerator we will have 3y minus 0.2x plus 0.1y. Now 0.2x can be rewritten as 0.4y plus 0.1y, that is 0.5y. So multiply this by 100%, you'll get your answer. Okay, so statement 1 alone sometimes do confuses the students. They simply assume that there is no liquid C in the green bucket, and they also assume that there is no liquid A and liquid B in the blue bucket, which is incorrect, which is like an assumption that's not given to us in the question. Okay, so here the answer is simply option number C. That is, when you combine both of them, then you'll get your answer. Okay, pause the video and try this question. This is comparatively easier with respect to the previous question. Okay, so pause the video and try this one, please. Okay, let's see what we can do with this one. So in a certain conference room, each row of chairs has the same number of chairs, and the number of rows is one less than the number of chairs in a row. How many chairs in a row? Okay, so let's say we have a certain number of rows, row 1, row 2, up till row n, and each row consists of, let's say, C number of chairs. Each row consists of C number of chairs. Now it's also given to us that each row of chairs has the same number of chairs. Okay, so each row has C chairs, and the number of rows is one less than the number of chairs in a row. So this value is basically C minus 1. So we have a total of C minus 1 rows, and each of C minus 1 rows consists of C chairs. Okay, so how many chairs are in a row? So first thing I can say that the number of chairs will simply be equal to C into C minus 1. The number of chairs will simply be equal to C into C minus 1. Okay, the first statement says that there are a total of 72 chairs. Okay, so which means C into C minus 1 is equal to 72. So now C into C minus 1 is what? C into C minus 1 is product of two consecutive numbers. Product of two consecutive numbers being 72, which means I have two possibilities. Possibility number 1 is the numbers are 8 and 9. Possibility number 2 is the numbers are minus 8 and minus 9. Now C represents the number of chairs, hence it can't be negative, which means the only possibility that we have is C being positive. The value of C has to be 8. Sorry, the value of C has to be 9. In that case, C minus 1 has to be 8. So each row consists of 9 chairs, and there are a total of 8 rows. So statement 1 alone is definitely sufficient to answer the question. Okay, statement number 2. After one chair is removed from the last row, there are a total of 17 chairs in the last 2 rows. Okay, so after one chair is removed from the last row, there are a total of 17 chairs in the last rows. Now every row consists of same number of chairs. That's a fact given to us. Each row of chairs has the same number of chairs. So let's say in second last we have C chairs. So in the last one we will have C minus 1. So this was statement 1. From statement 2 we will have C plus C minus 1 is equal to 17. 2C is equal to 18 and C is equal to 9. So each row consists of like 9 chairs. So how many chairs are there in a row? So again there are 9 chairs in a row. Alright, so we do have answers from both the statement, hence our answer will simply be option number D. That's our answer. Alright, let's move on to the next question. Pause the video and draw this question, please. Alright, let's see what we can do with this one. If Jim earns X dollars per hour, so Jim is earning X dollars an hour, it will take him 4 hours to earn exactly enough money to purchase a particular jacket, which means the cost of jacket will be 4x dollars because he's earning X dollars an hour. and it will take him 4 hours to earn exactly enough money to purchase a particular jacket. That means the jacket will cost 4x dollars. Tom earns Y dollar per hour. It will take him exactly 5 hours to earn enough money to purchase the same jacket. So the cost of jacket will be equal to 5Y dollars. Now the jacket is same, which means 4x is equal to 5y, or the value of x is equal to 1.2y, or the value of y will be equal to 0.8x. These two will be our equations. Now let's see what the two statements is. The statement number 1, Tom makes, now Tom is basically y, Tom makes 20% less per hour than Jim does. Jim is x. So the statement says that Tom makes, that is the value of y is 20% less than what Jim does, so that is x, minus 20% of x, so that is 0.2x. So y will be equal to 0.8x. Now this information is already with us. From the question itself we have this information. So this statement technically does not help us in finding out the value of x or y. And unless and until we can figure out the value of x or y, we won't be able to figure out what's the value of 4x or 5y. That means we can't figure out the value of the jacket or cost of the jacket, which means statement 1 is out. So if I have D, A, B, C, E, statement A alone is out, which means D is also out. Because if A alone cannot be our answer, which means both statements individually cannot be our answer also. Second says x plus y is equal to 43.75. Now from the question statement itself we have x which is 1.2y, y which is 0.8x. Now use either one of them and calculate the value of x and y, because we have x plus y is 43.75. Now what will be the exact value, that's not our concern. But if x is 1.2y, then you can say 2.2y will be 43.75, and we can calculate the y from here. Similarly, we can calculate the value of x also, because y is 0.8x, so 0.8x plus x is 43.75, we can calculate the value of x also from there. Now either ways, if you have the value of x, you have the value of y, can you calculate 4x or 5y? Yes, you can do that. Do we need statement number 1 for that? No, we don't need that, because the relationship between x and y is already given to us in the question itself, which means our answer is simply statement number B. Sorry, our answer is simply option number B, or statement number 2 alone is sufficient to answer the question. Okay, let's try one more question for this video. So pause the video and try this question, please. All right, let's see what we can do with this one. Bill runs a hot dog stand, and at the end of the day he has collected an assortment of $1, $5, and $10 bills. Okay, so we have $1, $5, and $10 bills. He discovers that the number of $1, $5, and $10 bills that he has is in the ratio 10:5:1. So the bills are in the ratio 10:5:1. Or we can say that their overall value will be 10x dollars. This will be 25x dollars, and this will be 10x dollars. Since the ratio is 10:5:1, so I considered the number of $1 bill to be 10x, number of $5 bill to be 5x, and number of $10 bill to be x, x being the ratio constant. So I'll have 10x, 25x, and 10x. How many $10 bill does he have? So we need to find out x basically, or effectively we are supposed to find out 1x, that in turn is simply equal to x. This is what we need to figure out. Okay, statement number 1. The dollar value of his $1 bills. Now the dollar value of his $1 bills is $10x equals to dollar value of his $10 bills, which is also equal to 10x, and this is something that we already know, right? This is $10x, this is also $10x. Now, so this statement 1 does not provide us with some extra piece of information which can help us in finding out the answer. So one alone will definitely not give us the solutions, which means A is out, which means D is out. Now second says Bill has a total of $225. Bill has a total of $225, which means 10x plus 25x plus 10x is equal to 225. So 45x is equal to 225, or x is equal to 5. So $1 total will be $50. $5 will be total of $125, and $10 will be a total of $50. So how many $10 bills does he have? Now if $10, the sum of the $10 bills is equal to 50, and that means he has a total of 5 bills of $10 each. So x is equal to 5. That means statement 2 alone will give us the required answer, which means the answer here is option number B. That's it. Okay, so that will be all as far as this video is concerned. Okay, thank you so much for watching the video. If you have any questions, if you have any query, if you have any concern, do let us know. Okay, if you're looking for any personalized classes for GMAT, GRE and SAT, you're more than welcome. You can contact us anytime. Okay, and please do subscribe to the channel and share it with your friends, and keep watching and keep learning, guys. Thank you so much.